We're doing a fresh pollen harvest with complete stamens from Magnolia officinalis. This is a species from China that is becoming scarce because of over-harvesting for the beneficial bark extract for medicinal purposes. So there are very few of these in North America that are yielding seed-producing groves so that we can readily distribute this in gardens and the nursery industry. So doing controlled pollinations that are intraspecific to create nice diverse populations of Magnolia officinalis is something that is a beneficial thing to consider currently with Magnolia hybridization. So this particular plant was collected in China in 2008 by Scott McMahon of the Atlanta Botanic Garden, and we've grown it out here. So this is a flower that's opening for the second time this evening. Magnolia officinalis is within subgenus Magnolia and has a very tight window of receptivity. So early in the evening, we can do the pollen transfer. So we've got a nice fresh pollen harvest from this individual, and to generate a little diversity within the species, we're not going to do a pollination to another flower on this tree. We're going to move to another Magnolia officinalis that originated at Arboretum Westpouilloux in Belgium. So it likely has a different seed source. There'll be a little bit of diversity, and hopefully we'll generate nice intra-specific hybrid seed and get a nice heavy aggregate of follicles that will distribute that seed to other gardens hopefully next year. Okay, so on the adjacent tree in our collection, we found a flower that we're seeing the first evidence of the displacement of the parule. And we can continue to pull those back and get to the outer rung of tepals. Gently unfold them, get to the inner whorl of tepals. And wow, very good example of fresh pistils with recoiled stigmatic surfaces, and you can see how tightly arranged the stamens are. Obviously this is a flower opening for the first time, so that should be very receptive to the pollen that we collected from the adjacent specimen of Magnolia officinalis. And because we harvested an abundance of stamens, and this is the only pollination we're going to do, we're just going to take that whole collection of stamens and brush those in there just like those were insect legs working their way over the pistils, and let that stay in there. Close that back up. Try and rest those tepals back in the reverse order of how we displaced them. And cross our fingers that we're going to have a nice healthy aggregate of follicles that we can harvest mini seed from. So sometimes Magnolia breeding is happenstance, and seeing that Magnolia fraseri was in bloom and we were able to reach a flower that was opening for the second evening in the male phase where the pollen was beginning to hiss, we harvested that directly from the tree. We've got some hope that this is going to work because last year we performed a Magnolia virginiana fraseri hybridization and got two good little hybrid plants out of it. So the happenstance here is this evening I really wasn't expecting to stumble on this plant and see that it was beginning to bloom pretty heavily. And now we've got to look at these flowers and figure out which ones are going to be at the right stage. So the first one we look at, fairly wide open and you can see that the pistils are discolored and no longer coiled at all. So they're no longer receptive, but also the stamens have already become displaced and many are missing. So this is a post-functional flower, and this is the third evening that it's opened. So it's still showy, but non-functional. On the adjacent branch, the pistils are discolored, so it's beyond the female phase. This is the second evening this is opened, but you can see the stamens are still tight at the base of the gynecium, and they will begin to pull away as the evening goes along, and they'll release pollen. So the group of magnolias that are in subgenus Magnolia, Magnolia grandiflora, Magnolia virginiana, tripetala, obovata, fraseri, they have very tight windows of time that they have receptivity of pollen to the pistils. Virginiana, fraseri are evening flowering plants. During daylight hours, you're not going to get successful pollination occur. So they're synchronized. So we got two North American native plants that are somewhat closely related. They're still in different sections within subgenus Magnolia, but we got a prior history of this hybridization working. So then we look for a flower that's got tighter tepals, and that tells us that it has freshly opened. So there's one on this little bit higher branch, and those tepals have never opened entirely, and when we further assist the opening, you can see that the pistil surfaces are still kind of a pale white in color and have a coiled structure to them. So that's going to be receptive to the pollen. So we can do a fresh pollen transfer, and you can see in the Magnolia fraseri that pollen readily comes out of those essentially sutures along the edge of each of the stamens, and readily comes off my finger and rests in the tepals. And that's how a natural pollinator would come across this. A beetle would crawl around in that and then fly where it was attracted to the floral scent and the heat that was being emitted by a receptive flower. But the pollinator it caught tonight was me. So we'll transfer the fraseri pollen to the virginiana, and we can carefully rub it on your finger. Or if you have an ample source of stamens and you really want to do the job well, we can just sort of do a stamen dump into the flower and coat it extensively with pollen from the fraseri. So hopefully we'll get a repeat of last year's success, and we'll put our tag indicating the date and the pollen parent on that pollination. So if we want to do pollen collection in advance, you can collect the flowers toward the end of their first day when they're in their female phase and remove all the tepals. So we're looking at Magnolia figo variety crucipes, the purple banana shrub here. So if we gently remove all the tepals and then pinch the gynecium out of the center, then they will stand upside down. And if you leave them that way overnight, that allows air circulation around the stamens. They're able to dehisce and shed the pollen in a controlled setting on a clean sheet of paper. So this is a good way to get a bulk of pollen if you're going to do multiple pollinations at one time. Within 12 hours, but certainly between the next 12 and 24 hours, we'll be able to have this paper folded and have a great quantity of pollen that we can dab and do transfers with. This is a flower that was freshly harvested that was already in the end of that male phase, and you can see the pollen has dehissed from the stamens, and that would be ready for a transfer right now. Here is a hybrid between Magnolia faviolata and Magnolia laevifolia. That hybridization was first done back in 2010, and these plants are a great example of hybrid vigor that you get from interspecific hybridization, most of the time in magnolias that are readily compatible with one another. Oftentimes you don't get hybrid vigor, but in most cases that's what we're seeing with some of these crosses, especially in the section Magnolia, which people commonly think of as banana shrubs. Very compatible interspecific crosses can be done. So the morphology of these flowers is just like other magnolias. You have tepals instead of petals. The morphology of those structures isn't distinctive between sepal and petal, so they're referred to as tepals. And these flowers that are fully open, you can see the reproductive structures. We have stamens and then a central gynoecium, which contains a number of pistils on that structure. So the way magnolias operate is the first time they open, they are in the female stage and they are receptive to pollen. Then that closes up, and the second time it opens the following day, the pistils are no longer receptive, and the stamens, the collective stamens are called the andrecium, those then release the pollen the second day. So each magnolia flower is dichogamous. It is self-incompatible because the pistils are not receptive, synchronized with the release of pollen. That forces the plant to transfer pollen from one flower to the other via a pollinator, typically a beetle, that actually crawls between those tepals in the early stages of flower opening. So the flowers we're looking here that are nice and pretty and wide open are no longer functional. They've either been pollinated successfully, fertilization has already begun. This flower is pretty, but it's no longer functional for breeding purposes. The one at the shorter axillary branch beneath it, right before we started investigating this outer covering over those tepals is called a perule. On this species of magnolia, the hybrid, it has a lot of endomentum on that outer perule. So when that begins to fall away, that's your first indication on section Magnolia magnolias that you've got a flower that is on the verge of opening and will be receptive in the female stage to pollen. So if we assist the flower in opening, we know we're the first pollinator to enter the flower. And when the pistils are coiled and have a little bit of a sheen to them, indicating they've got some moisture on the tip, that's going to be receptive to pollen adhering to those stigmatic surfaces. When you look at a newly opened flower, you can see the stamens are tightly adhered to the base of the gynoecium. And in these particular magnolias, you have a stalked gynoecium that's called stipitate. So all the stamens are very tight to the base of that, and if you pull them away, it sort of shows that stalked or stipitate morphology. So we can now get pollen and apply to this. So what we're going to do is throw another species into the mix. We've had previous success taking this hybrid and crossing it with the purple banana shrub, Magnolia figo variety crucipes. So yesterday we harvested flowers and dried down the stamens so they would dehisce and release that pollen. We did that indoors in a controlled environment, room temperature, and allowed that to stay dried overnight in this paper. So now we've got a ready source of pollen that we can then collect on our fingertips, gently reopen that flower and dab it on each of those pistils. And then close back the tepals, and we've covered those surfaces, so we're unlikely we're going to have another pollinator come along that competes with us there. And when you're doing interspecific magnolia hybridization, controlling that cross, that'd be nice to seal this up, but we're really not worried about that because the morphology of the parents are so different. When we germinate the seedling from this, the morphology is going to be apparent that the hybridization can be verified through morphology. If we were crossing two magnolias that were similar, I might want to be very careful, seal that up, and ensure there was no outside pollination that occurred. So what we'll do to remember our cross here, we've pre-written labels that have the pollen parent and today's date, and we will position that around the flower, and that will hang there all spring and summer as that fruit develops, and we'll be able to harvest that in probably the month of August to early September is when that will be ready for harvest. This plant is the result of crossing Magnolia faviolata, Magnolia levifolia, crossed to Magnolia figo variety crucipes. So this shows how the coloration in the tepals of the variety crucipes, purple banana shrub, is introgressed into this complex hybrid that now has 3 species within section Michelia. The bloom size is larger than your typical Magnolia figo. The gynoecium is very similar in its stipitate condition that it inherits primarily from the Magnolia faviolata, which gives it kind of a hibiscus flower similarity in the morphology. So quite showy and different than anything that's come about over the years in Magnolia hybridization. But when you look at the plant, it still has extreme hybrid vigor, and this could be a great garden plant, but gardens are getting smaller, and we want to keep breeding things down to smaller size. So going back and doing a back cross to the Magnolia figo variety crucipes, breeding in a little deeper color, giving the plant smaller foliage, tighter internodes, more compact habit, could make this even more desirable in the next generation. So we can do the same process and look for plants that have buds that are staged where that outer perioule is close to being shed, and then we can assist those open. And if we see that the pistils are coiled and the stamens are tight and haven't moved outward and begun to dehisce pollen, we know that's in the female stage. We can go to our pre-harvested pollen. Apply that to all of the pistil surfaces and gently close it back up, and then we'll put our tag on there indicating that that cross was made. And hopefully we can look forward in about 3 years having the offspring of this bloom and see that we have made further improvements in this hybridization process. So pollination in the greenhouse I've learned over the last 10 years, I can get much better success in fruit and seed formation, because in nature what's happening is that magnolia flower opens to receive the pollen, then it closes back up for the next day. So it's making its own greenhouse environment to facilitate pollen tube formation. So fertilization can occur within those first 12 hours after pollen transfer. A greenhouse environment gives you kind of double environmental benefit: high humidity, warmth. So that is my observation and why I believe that we get much better fruit and seed formation on container stock inside the greenhouse rather than plants in the landscape. So we have another opportunity here to do some breeding refinement within section Magnolia. This plant represents a hybrid of 3 different species within the section Magnolia. We got some good pink color, some large foliage, lots of buds. And what we can do now is do a back cross, because this hybrid involves Magnolia Figo variety Crassipes. If we want to get a little more compact growth, a little bit more pigment in the flower in the next generation, but also maybe gain some of the other advantages of cold hardiness and delayed flowering that we get from the Figo variety Crassipes parents, doing a back cross to this can hopefully accomplish that for us. So this was a freshly harvested flower, and we can do the same thing that we might do with advanced pollen collection, but we got to be a little bit more delicate because the stamens could also detach. And this gives us an opportunity, if we've got ample pollen to use, we can treat this flower, the detached tepals, like a brush, and we can insert it in that newly opening flower on our seed parent and brush it on much in the same manner that insect legs might brush up against the pistil surfaces. And then tighten it up a little bit, and we'll label that, and hopefully we've got a successful back cross that we've just performed. A quick overview of magnolia breeding and the pollination procedures to get successful fruit and seed development. The key with any magnolia cross you're doing is looking for the stage of flower development and recognizing whether it's a flower opening the first time in the female phase, the second time in the male phase, or if it's post-functional, and you'd be wasting your time working with a post-functional flower. So whether you're in subgenus Magnolia, like Magnolia officinalis, or whether you're in section Michelia of subgenus Eulania, the same principles apply. You've got to be in the right stage of floral development to get successful pollination. So we looked at examples of complex interspecific hybridization within section Michelia to refine breeding of hybrids that have been in development over the last decade, to continue to refine shape, cold hardiness, late blooming, and those are all ongoing breeding initiatives. In section Magnolia with officinalis, we did an intraspecific cross for the purposes of generating seed in a species that is not well distributed in cultivation and also endangered in its native habitat. Within section Magnolia, subgenus Magnolia, we looked at Magnolia fraseri and transferring pollen of it to Magnolia virginiana to create a unique interspecific cross of native species that has only been recently successfully done, and we hope to repeat that to make a very interesting combination of those native species. So Magnolia hybridization, there's not one right way to do it. As long as you understand the stages of flower development and basic compatibilities within different sections of the genus, you can be successful with a wide range of pollination attempts.